Is the following statement true, that for all integers a, b, and c, if a divides b and a divides c, then a divides the product of b and c? Well, first thing is, let's think of some examples. So what does it mean for something to divide something? We're basically saying if you have, let's say, 2 divides 4, can what on the right be written as a multiple of the left? So in this case, we're asking if 4 can be written as 2 times x. When we're looking at something else like 3 divides 9, we're asking the same problem. Can 9 be written as a multiple of 3? And then for 5 and let's say 5 and 20, can 20 be written as a multiple of 5? The important thing is that for all of these variables we have, they must be integers. So it must be that something on the right, it can be written as what's on the left multiplied by an integer. So let's have a look at just like these examples that I have over here. I'll keep this up so we can remember what divisibility really is. So if we're asking a multiplied by b and c, let's let a be, let's say, 2 and 4, and we're going to look at 2 and 6, right? Both of these are divisible by 2. So let's then say, okay, then does 2 divide 4 times 6? Well, 4 times 6 can be written as, we can take a multiple of 2 out of here, which is going to be the same as saying 2 times 3, right? Which is, at the end of the day, we're asking, can 2 divide 24? 2 times 3 is 6? What did I do wrong here? Oh, I made a pretty big mistake here. Keep the 6 there. There we go. So the answer is yes, this is obviously true. 2 does divide 4 because, 2 does divide 24 because 24 can be written as 2 times 12, where 12 is obviously an integer, right? The other thing to notice is, in other words, because 2 can be written as 2 times 12, can what's on the right here be written as 2 times some integer, right? Let's do one more example. Let's take 5 over here. So let's take 5 divides 10 and 5 divides, let's take 5 divides itself, right? It's true that 5 can be written as a multiple of 5. It just have to be 5 times 1. So anyways, what we're then asking is, can 5 divide the product of 10 and 5? So 10 times 5. We can, of course, pull out a 5 out of here. So we can say, well, we don't need to pull out a 5. This is the same as asking this. And obviously, we can see that what's on the right can be written as a multiple of what's on the left multiplied by some integer. But let's, for completeness, just finish this. We're asking, can 5 divide 50? And the answer is, of course, that's true because 50 can be written as 5 times 10, where 10 is an integer. So it's looking like this statement is true, so let's go ahead and try and prove it. So before we start our proof, we obviously need the actual concrete definition of divisibility, which is going to be that the definition of divisibility is that for any 2 integers, let's say a and b, they are such that a divides b, so b can be written as a times k for some integer k. And the last condition that people always forget, and a cannot be 0. Why do we add this last statement here? Because if, let's say, you have 0 divides 5, we're asking, can 5 be written as 0 times some integer k? And obviously that's not true, because if you want to find what k is here, you would be asking 5 dividing by 0, and you cannot divide something by 0. Or more generally, if you take 0 divides b, you're basically asking, can b be written as 0 times k? And obviously, if you want to figure out what k is, like when we said 5 divides 10, 10 is equal to 5 times k. If you want to find what k is, you just rearrange for k, and you find k is equal to 2. If you want to find what k is when a is equal to 0, you're doing b divided by 0 is equal to k, which can't be done because you can't divide something by 0. That's why it's so important to add this final statement here that what's on the left cannot be equal to 0. Okay, now we can start writing our actual proof. So this is a for all proof. How do we start our for all proofs? Well, you start with the word let. We say let a and b be integers such that a divides b and a is not equal to 0. Then, now we want to unpack what we mean by divisibility. We can't really use this in math, so we want to put it in a form that looks like this up here. So we say then b divides a, b is a multiple of a, where b can be written as a times k for some integer k. Now that we've defined everything and supposed everything we needed to, we can now check if this down here, I see, the other thing I forgot to say. I need to add another variable here, a, b, c, such that a divides b and a divides c and a is not equal to 0. We can then say, then b can be written as a multiple of a for some integer k, and c can be written as a multiple of a where a is multiplied by m for some integer m. Remember not to use the same variable, because if you start using the same variable, you're saying, hey, b is actually the same as c. These two are equal, which they're not. We don't know if b and c are equal. We're trying to solve it for all different combinations of b and c where this is going to be true. So anyways, now we can start to unpack our definition. We're going to try and get what's on the right to look like what's on the left, which in this case is a, multiplied by something in a huge bracket where what's in this bracket has to be an integer. That's what we're going to try and get. So let's start by writing down next b times c is the same as saying a times k multiplied by a times m. Now, you can of course pull out an a here, right? We don't need the brackets. This is the same as saying a times k times a times m. You can simplify this a little more. This is the same as a squared times km. You don't have to really do this. I think from here, you can just immediately jump to saying a factored out times a km, where a km is in fact an integer. You can maybe, if you wanted to, factor out an a squared and then argue km is an integer and then say that, of course, a divides into a squared. But I'm just going to strictly stick to our definition of divisibility and our goal to prove that it is divisible. So we can then say, in conclusion, a divides bc because bc is equal to a times a km. So bc is in fact a multiple of a. You can probably just say in conclusion a divides b, but I like to be very explicit as to why. It's because b and c can be written as a times something, so b is in fact a multiple of a, which by definition of divisibility makes a divide bc. So fantastic, we've proven this now.